Hello, my name is Marcus Rydell, and I'm going to show you a bit about how to implement a modular monolith using a TypeScript stack for the backend. Okay, so first of all, let's take a look at some existing code where basically everything related to this project exists in a single file, and I'll walk you through it. Also have some simple tests that are pretty bad, but in kind of integration tests. Now we're using Prisma, Express, and TypeScript of course, and we have some kind of service, application that we'll listen to, and then it starts up, and that's to make it testable, but inside of app.ts is the main bulk of the code. So running through the code, oh, and by the way, so here we see app factory, and for those using Java and C#, it's basically a constructor. So this should be pretty simple to rewrite as a constructor that takes no arguments and then sets everything up. Okay, so we set up a Express app, add support for JSON. We create the database driver. We're using Prisma as an ORM. And the main thing that this represents is a database connection pool. And that will usually be shared across all the different parts of the system because most of your system will work against your database. Then I add some kind of status endpoint, so it's simple to see that everything is up and running. On slash, I serve the postman information if you want to import that and do postman calls again against this API. It's just documentation. So below 22, here's where the actual code starts. So we have an API where we add some kind of entity that we call challenges, and for this project it's a code typing. You're supposed to write code challenges, and there's so little code so it doesn't really matter that much. We just have something called challenges. You can get the challenges, find many. You can get a single challenge by ID. We have some simple validation, and we can post, so we can create a challenge. And then we have a bit of contrived business logic here. It's like checking if it's Monday, then we change the value of level. And that's just to show that if we have something that's non-deterministic, that if the value of level will change depending on the day of the week, then that is kind of hard to test. So we need to think about testability here. And the business logic here for create is quite a bit more substantial compared to when you get something, for example. And then we have a delete as well, but yeah, that we don't have to focus on that much. We don't have an update, but we basically need to focus on create the most, and then maybe get as well. So let's revert, close that down, and see then how we could organize this as a modular monolith. And for that, we'll do a git checkout, jump back to the code, and now we have a little bit more structure. You say I'm using the word modules here, and in the previous video I called it kits, which is the word I would recommend moving forward. For this recording, I'll just stick with modules though. Okay, so if you look at the app.ts and what it does, then you see it sets up the Express app again with JSON support. We have the status endpoint. We have the postman JSON again. So everything looks kind of similar. And then you see Prisma client, but after that we have challenges module factory. And then we see app.use API challenges module router factory. So what's going on here? So basically, now we get an overview of our challenges module, where we say that it depends on the Prisma client to have access to the database. We also see that our entire API consists only of challenges, where it has a bunch of sub routes defined internally in challenges. So here we get an overview of our dependencies and the high-level API that we offer to our clients. And then we have a bit of error handling. I will actually not go into the error handling part that much. Let's stay focused on the actual modular part of the code. But just know that here, if you add more modules, then it's basically line 22 that will be duplicated for your products module or whatever module you have. And then you would send in all the dependencies required here. And same thing with the router factory and setting up the routing, that you would get a pretty nice overview in one file, but you will not get a lot of details. So if you care about the actual challenges API, for example, you can go into the router factory and let's see here. And then you can see that we have get by ID, post, delete, and that's it. And if you look at post specifically, if you remember how big it was, now we're using thin controllers here, where we just extract what we need from the request body, and then we give pure deterministic inputs to service.create, and then we return JSON. And basically you can see this pattern on all of them except for get all, because it doesn't require any real input. So it has one line less. But there's a pattern here. And you can actually, if you want to, extract this to some kind of abstraction that creates most of the code for you. I would not recommend it. This is a course more oriented for beginners. Just accept the boilerplate you have here and be happy with it. So that was the routing part. And if we go and let's check the file system. So I want the file system to tell a story. So here we see that we have a folder named modules. And inside of it, we have challenges. And depending on how far you want to take it, this is as far as I usually go. For the beginners, I would not have these nested subfolders, but on a more advanced level, I do like it, because now I visualize all the different actions, the way you can interact with the challenges module. So let's start with the index file. There's not a lot going on in the index files normally. Normally I reserve the index files to re-export stuff, to make it public to the folder above, and also to basically create things and compose them together. So create and compose, that's it. Usually, unless it's a very, very small thing, I don't have logic together with whatever creates the stuff. So here we can see that we don't actually depend directly on Prisma anymore, because I want the module to be as separate from the outside world, meaning it shouldn't know about Prisma. Now I'm being a bit pragmatic here and cheating. So DB, that type, is a type alias for a few things that comes from Prisma. So let's take a look at that. Just know that it's language specific here. So export type DB equals, and then from the Prisma client that I send in, I only pick what I need. And here we see challenge row. So we'll take a look at inside of the code what that actually means. Just know that from Prisma client, we can now only access the challenge row property. And that actually modularizes the database inside of here. Now I can't access something that doesn't belong to this module inside of the database layer, which is the whole point of modules, that we want to have these vertical clear boundaries. So also another thing, what I return here, I always return the service, because for me that's the top layer. Now, classically we have seen the controller layer or routing layer as the top layer, because that will then call the service layer. But I see the controller or router as a way in, like a port into the service. And that can take some kind of input, adapts it to what the services needs, and there are multiple ways that we might use to talk to the service. You might use the terminal, you might do some kind of simple script in TypeScript or WebSockets, AMQP, whatever. So this is just one of the ways you can mount your service in a way where it can talk to Express, for example. But you can have a bunch of different factories that will then connect your service into some kind of controller layer. So the service layer should also be exposed, because then we have direct access to it wherever and however we want to use it. Let's take a look at the service factory then, if I can get into it. Thank you. Now, this is probably going too far if you start out with this kind of a modular architecture, because now you're just, again, you're creating and composing. So here we have factory functions that all depend on the database. And then you get some kind of function back. And this in turn enables you to return the service from the module. You could inline what you will see in get all factory. And if we take a look, remember how simple get all was. So if we go in here, it's just a single row. So you could just, I guess, take this part here and it will still work the same. And that's fine. You can do it. I would recommend you doing it the first time. The reason why I add a little bit extra is to show you that the modular pattern is fractal. So in the same way that the challenges module will be vertically separated from other modules in the future, then these methods here are vertically separated from each other as well. So if you have a lot of messy or like complex business logic, it can actually be pretty nice to create some extra vertical boundaries inside of your module. So what that looks like is that, for example, if you look at the file tree here, get all, you just have an index file. So this is basically not value. But if we look at create, there's some more files. So here we have something called logic.test.ts, where we have unit tests, where we have, for example, simple challenge is scored as level 1, and there's a way to test that. And then simple challenge on Monday is scored as level 2. And there's not that much going on with this test. There's a bunch of setup for the, this is the range. Here we have the act, and it's calling the logic function, which we will take a look at. And then just asserting that we got the right result back. And now it's deterministic. All right? So that's pretty neat. And it's also a bit simpler to reason about that this logic.test.ts is only concerned about the logic, the business logic of the create function. It's so getting an overview of how the create function works, it's pretty simple. Let's go to the index file for the create function. So here we have the create factory. It will require and this is the constructor then. So sorry, object-oriented people, you'll see 2 parentheses, but that's because this is the constructor, this is the actual method. Okay, so we depend on the database. If you wanted to, you could mock it, but I won't because I don't feel the need to. So I will do a mockless testing strategy by extracting the business logic to its own logic function. Now, when we call the method, which is actually the create method, then we need some kind of input. And I will show you how I set up the input, but I'm using SOD. So inside of my create factory, I need to make sure that the raw input is actually of type input. So some of you might do unknown instead, but then it's hard to use this code if you use TypeScript scripts to execute the code. So in some cases, you actually know what input you need, and you want TypeScript to also help with autocomplete when you call the function, the method. So it's better to have input as a type here for those cases where you actually script. And then during runtime, when you use a controller or something like that, where you don't explicitly control the input, then you need to parse it. And we could see that we had the input in its own file as well. So tiny files to separate concerns. We can also see that we return UUID v4 here as an ID, which is non-deterministic. It's randomized. We also have new date, get day, today, weekday. This is also non-deterministic. It will vary, that you will not get the same result 2 days in a row. Usually not, at least. Dates are tricky. So now when we have all of the inputs deterministic, then we can hand it forward to a logic function that then takes ID, name, content, today, weekday. And the logic function will be entirely deterministic, and it will return a deterministic response from that. And now you can send it to the database and create whatever you want to. And disregard line 20, it's if you have the same ID twice, that will be a validation error. So that is why it's here. It should usually be something else than a validation error. It could be a connection error, etc. But let's not focus on the error handling in this case. Now, if everything went fine, we'll return the ID of the resource that we created. So let's jump into the logic function. So inside of here, we have a bunch of if statements. So for me, any kind of control flow in your code usually represents enough business logic to deserve to be tested. There are some cases where you just have a simple process and with check in an if statement and that's it. So then I don't count it as enough logic to test. But this is a pretty good use case for enough logic for us to actually make sure that we want to make sure that the code behaves as we expect it to. And this is very small and it's very isolated from any other method in the challenges module, and the challenges module is then very separated from other modules. Now, you can find this code in github.com/marcusredell/code_typing, if you want to check it out. And then you should look at final modular monolith. One thing that I don't go into here is if you have another module and you do need some, and usually that will be some kind of user module or account module or identity module. And usually you will have some dependencies on that you need inside of challenges module, for example. And so maybe you have the user ID, but you actually want to show the name of the user and mix that with the challenges data that you send to the client. And there are ways to enable that by connecting the services with each other. And that's another video. I will not record it like today, but I will take a look at recording it in a while. So until then, take care.